For this example of looking at controlled release fertilizer calculations, we know we're going to use the rate of 8 pounds per cubic yard, and we're going to use a 16-9-12 formulation of a controlled release fertilizer. Now we know how much fertilizer we're going to put in a cubic yard, and we can just scale that up for however many yards that we're going to mix up. The question here I want to answer is how many pounds of the specific nutrients, nitrogen, phosphorus, and potassium, are we getting out of that 8 pounds of the CRF product? So we know that we have 8 pounds, and we know that only 16% of that is actually nitrogen. So we're going to multiply that by 0.16, and that will give us 1.28 pounds of nitrogen. Now we're going to use the same thing for looking at the phosphorus and the potassium. But with phosphorus, we know that this 9% is actually phosphate. And of that 9%, only 43% of that is actually phosphorus. So first we have to account for that. So we know that we have 9% phosphate, and of phosphate, 43% of that is actual P, or phosphorus. So our actual phosphorus rate is 0.0387 amount of phosphorus, or a little over 3% phosphorus. So we're going to multiply that by our 8 pounds of 16-9-12, the total amount of product that we're going to put down, and that equals 0.309 pounds of phosphorus. And the same process goes for our potassium. Now that 12% is actually potash, so we're going to take the 0.12, which is the potash, multiply that by 0.83%, or 83% of that 12% of potash is actually potassium. So that lets us know that there is just under 10%, or 9.9% potassium in that potash, or in this 16-9-12 controlled release fertilizer product. So we want to multiply that by 8 pounds of the product, and that will give us 0.7968 pounds of K. Okay, now we're going to use our controlled release fertilizer calculations and work backwards. Our previous example told us that we were going to get 1.28 pounds of nitrogen from a 16-9-12 product. But let's say we don't have that 16-9-12 product on hand right now. All we have is a 14-4-14 product. But we want to have the same delivery rate of nitrogen. So we can make that happen. So the first thing that we need to do is we need to know that we need X pounds of product, and that's our 14-4-14. And if we multiply that by our percent nitrogen, which is 0.14, we want that to equal 1.28 pounds of nitrogen. So we just do some simple algebra here, and we divide both sides by 0.14, and we'll get rid of that 0.14, and we find out that we need 9.14 pounds of 14-4-14 to get 1.28 pounds of nitrogen.